Hello students, myself Mehul Kodia. So in this lecture we have to discuss one topic that is from acceleration analysis chapter, that is Corioli's component. Okay, so in today's session we have to discuss Corioli's component of acceleration. Okay, so what is Corioli's component, how to draw Corioli's component, we have to discuss in this lecture. So when a point on one link is sliding along another rotating link, such as in quick return motion mechanism, then the Corioli's component of the acceleration must be calculated as shown in figure. Consider a link OA and slider B as shown in figure A. Okay, the slider B move along the link OA and the point C is the coincident point on the link OA. Okay, you have to understand based on the diagram. Now we have to discuss that. We have to consider some component. Let omega is equal to angular velocity of the link OA at time t second, and small v is equal to velocity of the slider B along the link OA at time t second, and omega into r, as you all know, velocity of the slider B with respect to O perpendicular to the link OA at time t second, and omega plus delta omega, comma v plus delta v, and omega plus delta w, omega plus delta omega into r plus delta r is equal to corresponding value at time t plus delta t second. Okay, now we have to understand that. Let us now find out the acceleration of the slider B with respect to O and with respect to its coincident point C lying on the link OA. Okay, now figure B show the velocity diagram when their velocity v and v plus delta v are considered. In this diagram, the vector bb1 represent the change in velocity in time delta t second. Okay, the vector bx represent the component of change of velocity bb1 along OA, for example along radial direction, and vector xb1 represent the component of change of velocity bb1 in the direction perpendicular to OA, for example tangential direction. Okay, now we have to discuss on another diagram. Therefore bx is equal to ox minus ob based on the vector triangle, clear, is equal to v plus delta v cos delta theta. Clear? Since delta theta is very small, therefore substitute cos delta theta is equal to 1, because the minimum value of cos, that is 1, and the minimum value of cos, that is minus 1, and maximum value of cos, that is 1. Now bx is equal to v plus delta v minus v, that's why plus v and minus v cancel out, so answer is delta v acting radially outward direction, and xb1 is equal to v plus delta v into sin delta theta. Now delta theta is very small, therefore substitute sin delta theta is equal to delta theta. We have xb1 is equal to v plus delta v into delta theta. Okay, now we have to multiply the delta theta inside the bracket, is equal to v into delta theta plus delta v into delta theta. Okay, neglecting delta v into delta theta being very small, therefore xb1 is equal to v into delta theta. This is simple mathematical expression. Okay, now we have to understand Corioli's component of acceleration. Okay, so in Corioli's component of acceleration, figure C show the velocity diagram when the velocity omega into r and omega plus delta v into r plus delta r are considered. In this diagram, vector bb1 represent the change in velocity. Okay, this is the diagram number C. Clear? Corioli's component of acceleration, there is 3 diagram. Okay, vector yb1 represent the component of change of velocity bb1 along OA along radial direction, and vector by represent the component of change of velocity bb1 in direction perpendicular to OA, for example in a tangential direction. Therefore we can write yb1 is equal to omega 1 plus delta omega in bracket r plus delta r into sin delta theta in downward direction is equal to omega r plus omega into delta r plus delta omega into r plus delta omega into delta r into sine delta theta. Okay. Now this is a simple mathematical expression. Since delta theta is very small, therefore substitute delta theta is equal to sine delta theta is equal to delta theta. In the above expression, we have yb1 is equal to omega r into delta theta plus omega into delta r into delta theta plus delta omega r into delta theta plus delta omega delta r into delta theta. Now neglecting all other quantities, and we get the answer, that is omega into r delta theta in downward direction, radially inward direction, and by is equal to y minus ob based on vector triangle omega plus delta omega in bracket r plus delta r into cos delta theta minus omega into r. Now we can modify this expression as below: omega r plus omega into delta r plus delta omega into r plus delta omega into delta r into cos theta minus omega into r. Okay, since delta theta is very small, as you all know, therefore substitute cos delta theta is equal to 1. We have by is equal to omega into r plus omega into delta r plus delta omega into r plus delta omega into delta r minus omega into r is equal to, now remove the opposite and same direction quantities, and you will get the final answer omega into delta r plus r into delta omega. Okay, therefore total component of change of velocity along radial direction, that is bx minus yb1 is equal to del v minus omega r del theta, in actually acting radially outward from O to A. Okay, now we have to understand Corioli's component of acceleration in radial component. Okay, radial component of acceleration of the slider B with respect to O on the link OA acting radially outward from O to A. Now acceleration at BO is equal to LT del V minus omega r del theta upon delta theta. Clear? Minus omega r into d theta by dt is equal to del V by del t minus omega square into r in upward direction. Okay. Now also the total component of change of velocity along tangential direction, that is xb1 plus by, is equal to v into delta theta plus omega into delta r plus r into delta omega. Now tangential component of acceleration of the slider B with respect to O on the link OA acting perpendicular to OA and towards left. So acceleration at BO is equal to limit v delta theta plus omega delta r plus r delta omega upon delta theta is equal to v d theta by dt plus omega dr by dt plus r d omega by dt is equal to v into omega plus omega into v plus r into alpha. Alpha is nothing but that is angular acceleration is equal to, in bracket, 2 times v into omega plus r into alpha. Okay. So this is nothing but simple mathematical operation. Now radial component of acceleration of coincident point C with respect to O acting in direction from C to O. That is acceleration at CO is equal to omega square into r in upward direction, and tangential component of acceleration of the coincident point C with respect to O acting in direction perpendicular to CO and towards left. Acceleration at CO is equal to alpha into r in upward direction. Radial component of the slider B with respect to the coincident point C on the link OA acting radially outward direction. So acceleration at BC is equal to acceleration at BO minus acceleration at CO is equal to dv by dt minus omega square into r minus, in bracket, minus omega square into r is equal to dv by dt in upward direction. Simple mathematical expression. Okay. Now the tangential component of the slider B with respect to the coincident point C on the link OA acting in direction perpendicular to OA and towards left. So acceleration at BC is equal to acceleration at BO minus acceleration at CO. All are tangential. Acceleration is equal to 2 omega v plus alpha into r minus alpha into r is equal to 2 times omega into v. Okay, this tangential component of acceleration of the slider B with respect to coincident point C on the link is known as Corioli's component of acceleration and is always perpendicular to the link. Okay, now Corioli's component of the acceleration of B with respect to c, that is acceleration at bc is equal to 2 times omega into v, where omega is equal to angular velocity of the link OA and v is equal to velocity of slider B with respect to coincident point C. Okay. Now, in the above discussion, the anti-clockwise direction of omega and radially outward direction of v are taken as positive. It may be not that the direction of Coriolis component of acceleration change sign if either omega or v is reverse in direction. But the direction of Coriolis component of acceleration will not be changed in sign if both omega and v are reverse in direction. It is concluded that the direction of Coriolis component of acceleration is obtained by rotating v at 90 degree about its origin in same direction as that of omega. Okay. Now, Coriolis component of acceleration you can understand based on this diagram. Clear? There is a total 4 position is defined. The direction of Coriolis component of acceleration, that is 2 times omega into v for all 4 possible cases as shown in figure. The direction of omega and v are given. Clear? Direction of omega and v are given in this diagram. Okay. So next topic we will learn in our next lecture. Thank you.